So yeah, edge security in untrusted environments, and when we're talking about untrusted edge, I mean we're talking about like real life untrusted edge, as in real life, as in this is a real picture of a real scenario that I'm talking about. So you have a Raspberry Pi in what clearly looks like a home or a small business or something that's a very informal environment, and there's this access point, which is a $20 piece of hardware that's hooked up to who knows what. So we don't know what's going on there, and yet there are a lot of cases like I'm about to introduce where we need to be able to create some trust from that Raspberry Pi on the untrusted hardware in the untrusted environment through the untrusted network, and come to some secure something or another, right? Something that requires trust, requires identity. So about myself, hi, my name is Issac Goldstand. I love smart homes, right? As a child, I was a huge Jetson fan, and when I saw the arms coming out making coffee for George Jetson and his wife and the flying cars and all, it wasn't science fiction. It was a documentary of what things would be looking like. And I don't know, in 2010, 2020, and we've gotten here. And so there aren't so many robotic arms, although, if people have been watching, the net about a month ago and saw the really cool dancing robots getting pretty close. Likewise, we don't have flying cars. We have the flying quadcopters, right? And this is just the natural. Of course, tech is going to go with that for me. I've also got about 20 years as an experienced architect, systems architect, software architect, cloud architect, you name it. I've done it. And I'm now the chief architect for a massive hybrid cloud platform that we're developing here at Amdocs. But if we, rewind a year and a little bit, in December 2019, I quit my job, not at Amdocs, to start the smart home company in 2019, and what I'm going to show you over the next half an hour or so are as a peek behind the curtains at techniques that I actually used. And I only had one problem, March 2020. So I couldn't get parts. Coronavirus had hit. People didn't want to, even parts aside, people didn't want to be spending, extra money on making their homes smarter, because no one knew what was going to happen. And here we are a year later, and economies are slowly opening, but at the end of the day, no one knows what's going to happen, and it's still a bad business. So that's that. But let's talk. Let's take a little trip down my memory lane and talk about a lot of cool open source on the way. So before I really get into the HashiCorp specific stuff, I decided that the smart home business was going to be probably powered by awesomeness, right? And we can see we have HashiCorp Vault and console in here, Trafic, Let's Encrypt, Desmodo OpenVPN, Cloudflare, Dockers and Kubernetes. And although this is Hashi Talks, and we're going to give the stage back to HashiCorp in a second, I want to make an extra special shout out to the amazing people and team, Home Assistant, and to the amazing people at Nabukasa, which is the small startup company that was formed as basically the Home Assistant Foundation, so that it could pay people to be working full time on the project. Home Assistant is an amazing project. If any of you guys are actually looking to automate your homes, highly suggest that you look into it. I've been a happy user for 5 years. I built this business around it. And you guys are all amazing. The whole community there, Paulus and Pascal and Frank and all of you guys, you're all amazing. Thank you. So use cases. So there are 3 use cases that I use around security and Vault and the kind of stuff that I kind of want to talk about. We're only going to cover the first 2 in this because I couldn't get the third in to the time limit on these presentations. So the first use case is secured WAN access, right? You want to access your smart home from your Android or from your iPhone or from a web browser on your laptop. How do you get that working, all the way back? The second one is secure centralized backups, right? So Home Assistant is a project, a community. I'm providing a service around it, and therefore it behooves me to be able to back up your data, because if uh, your 5-year-old child drops the Raspberry Pi on the floor and something breaks and you lose all your data, right? If you're paying me money as a service provider, I better have a plan for that. And the third is a secured chip configuration registry. You have a lot of makers out in the community today, a lot of people doing their own chips based on ESP chips based on whatnot. And you have the classic way of working is you either configure everything over an untrusted HTTP socket, or you need to have some secure chip configuration registry where you could kind of zero conf those chips in. So again, we're going to cover the first two. The third is kind of going to be homework for people who are really interested. So let's start off with secure WAN access. And this is what it looks like, right? On the far left, we have the website, the portal, the app, whatever it is. It's going to go through some CDN edge location to hit some secure gateway, right? Because you're going to want something that's always up. Your device may not always be up. So, we want to have something that says, hey, I'm alive, but the device might not be. And then there's going to be a managed VPN connection between that secure gateway and your home. And inside your home, you're going to have your home Wi-Fi. You're going to have, that HasIO device, which is the Raspberry Pi that we saw at the beginning. And you're going to have all sorts of connected devices. And those connected devices are here for a reason. And that reason is because, if the picture on the first slide didn't scare you, those connected devices will, because that's how hackers get into the network. Right? They have unsecured devices like camera, whatnot, and we don't know what's going on. We don't know who's sharing the network with us, and that's critical, because one edge of this secure trust relationship that we're going to get with is going to be sitting with all those devices, and we just have to deal with that. So, starting from the left, it's really easy. We have a TLS connection provided by Cloudflare to their CDN edge. And then we have Let's Encrypt powering another TLS connection between them and some server head-in that I have. And then on the right side, we're going to have a different kind of connection. We're going to have OpenVPN, which is also over TLS. It's going to be connecting point to point between the secure gateway and that hardware device, so that people can snoop in on it from the network. And for the duration of this conversation, we're really going to focus on the right side of the picture, and we're going to talk a little bit about how we secure this OpenVPN point-to-point connection. How do we know how to establish trust between the HasIO device on the far right and the secure gateway on the left? And to do this, we're going to use a product called HashiCorp Vault. This is an intermediate presentation, so I hope most of you know what it is, but just to go through for those who might not be as familiar, HashiCorp Vault is a tool that provides dynamic secret management. It's an open source tool, and with all sorts of backends. So backends could be secret management for databases, secret management for access to cloud providers, secret management for public key infrastructure, right? A PKI, HTTPS, TLS connections that have a key and a CA and an X509 certificate that establishes identity, which we're going to come back to in a moment. We also have Vault also has this concept of encryption in transit, or this pass-through encryption, for people who are more familiar with public cloud offerings, like say AWS has KMS, which gives you encrypt and decrypt. Right. So the idea here is the same. Vault will manage these keys for you or sets of keys that you could just encrypt and decrypt, and the keys will always stay in the private storage. There are also key value static stores, and many other great backends. If you haven't looked at it and you work with security, you work with anything that involves secret management, take a look. Another prerequisite to before we go a little bit further is explaining the Home Assistant add-on model. So Home Assistant is a piece of software written in Python. It started as kind of a standalone, and it expanded. And as they wanted it to be easier to install, easier to manage, the team there understood that the easiest way to do it would be based on Docker interfaces. And so Home Assistant is divided into a whole bunch of Docker images. So at the beginning, you have the HasIO supervisor. The HasIO supervisor is basically the container orchestrator. for people who are familiar with Kubernetes or with Vault, no, sorry, with HashiCorp Nomad, right? The supervisor has a similar job, but the supervisor, first of all, it does more than only that. And second of all, the supervisor, has these managed expectations of what kind of containers exist in the ecosystem and where they are and how they communicate with each other in a way that's very tailored to the use of a home assistant. Other than that, you have another container called Hasio Core. That's the main, right, of people who've used it, and you get that blue login screen and where you see all of your devices and all that stuff. That's actually being powered by the Hasio Core. That's the Python program. There are a whole bunch of other containers that are managed internally, kind of like core add-ons. And then you have user add-ons, right? And add-ons are basically more containers that have a predefined interface and a predefined ways of sharing data between each other, whether it's directly between them or exposing network ports or whatever else they may need to do. As part of my business model, because I wanted to have an unmodified as possible home assistant so that I could have different tiers of users, right? I could have users that are managing everything for them, but I could also have these power users that say, hey, I want to manage my own home assistant, but I want, a subset of your paid features to kind of mesh into it. And to be able to offer that kind of flexibility, I chose to use these add-ons, these container models, to manage the ecosystem. So having said that, the first foundation that we need to have between the downstream HasIO and the upstream secure gateway is to have identity, right? Who are you? How do I establish this basic trust? We do that by authenticating to HashiCorp Vault. Now, once upon a time, HashiCorp Vault was just an API, and you'd connect to it. You'd get a token, which is basically Vault's assertion of your identity, and it's attached to all the roles that you have access to and the session timeout, etc. Happily, in the past few years, Vault's shipped with a utility called an agent. It's actually part of the same CLI, but functionally, it has its own, standalone purpose. And this is basically an agent that's just going to stay running as a daemon in the background, managing the session lifetime for you, extending this whatever secrets have and need to be renewed. Also, acting as a logical separation point between things that know about your credentials, how you authenticate to Vault, and other processes which just kind of assume that you're already authenticated, so you don't have to deal with that. So we have this, the first plugin is this isolated container. It's the only one that knows anything about authentication. And the first thing that it does is that authenticates to Vault using these long-term credentials that are configured for it, which is your username and password that you use to log into the system. The first thing it's gonna come up, it's gonna talk to HashiCorp Vault, it's gonna authenticate, it's gonna get a Vault token, it's gonna cache the token locally, and then it's just gonna sit there. Okay, and we're gonna come back to it in a moment when we talk about the VPN client. But before we talk about the VPN client, we need to talk a little bit about the VPN server. So for the OpenVPN connection, for the trust between the client and the server, I chose to use TLS, in other words, X509 based server and client certificates, also generally known as MTLS, mutual TLS. So Vault is we mentioned earlier, has this PKI management, and it knows how to manage the entire certificate authority and all the intermediate routes and all the leaf certificates. So the first thing that needs to come up is that on the secure gateway, which is running inside of Kubernetes, every time I spin up an OpenVPN server, that needs to get a newly minted certificate whose lifetime is managed by Vault, which is going to be tied in to that certificate authority, to the same certificate authority that we're going to use to establish that mutual trust. So on the server side, we actually use the Vault Agent Injector, very similar to what we just discussed on the client, except that Kubernetes is going to be trusted to manage the authentication, the identity of the user of the pod that's being run. And so what logically happens is that when I bring up a pod, I add some extra annotations. Those annotations are read by Kubernetes and its integration with HashiCorp Vault. And what's going to happen is that it's going to say, oh, hey, this pod wants some Vault specific stuff inside of it. So I'm going to run the Vault agent. I'm going to authenticate, and I'm going to request some secrets for the purpose of whatever is running on the pod. And inside the pod is going to be OpenVPN. So when the pod comes up and the agent injector comes, well, first the agent injector is going to come up. It's going to request an X509 server certificate for the VPN connection. Vault is going to return it, and then the OpenVPN container is going to start running in the pod, and it's going to use those certificates, the private and public key and the CA certificate that were just provided by Vault. And let's see what that looks like in code. So this is the code for the stateful set that's running VPNs, actually daemon set. I'm not going into any of the OpenVPN stuff. We're just going to look at the annotations here and see how the Vault side works. So you see that here in the annotation, we have a whole bunch of stuff. First, we tell it what role we're requesting, right? We want to be a VPN server. We tell it to enable a cache so that if the VPN server cycles, we don't have to get everything again. We still have the connection cache and the token cache. And most importantly, we have the CA certificate. Not the CA certificate, the server certificate cache. So we don't have to re-request that anytime the VPN, the OpenVPN software resets. We set also the TLS server name that we're going to want, right? That's the common name that's going to be showing up inside the VPN to vault.my.home. And we're going to tell it to inject itself and to inject the Vault token so that the OpenVPN software or other modules, rather in this case, running inside the context, inside that same pod, can also have access to the agent later. And that's because we have some custom scripts that work with the OpenVPN that do other things with Vault that we're not going to get. But the token is there for them, and therefore they don't need to re-authenticate. Same as we're going to see with the client. They're just able to use that agent there. And then the next thing that we have is we ask the Vault agent to inject the secrets that we want. So it's going to go to the OVPN. OpenVPN is a PKI backend inside of Vault. And we're going to ask it to issue a server role certificate with the common name of vpn.my.home and give it a 90-day TTL. It's split into 3 parts, but Vault agent knows to cache this. It knows that it's a single request, and then it takes different parts of the response out. So we have the issuing CA, which is going to be the CA certificate. We have the server.crt, which is going to be the server certificate, and we have the server.key, which is going to be the server private key. The only other one little thing of interest is at the bottom. So OpenVPN is very sensitive to the file permissions. These are all going to be written with 644 or whatever else your default UMask is on the system running. But Vault, if I brought up OpenVPN with that, it would say, hey, your private key isn't secure, isn't protected well enough. I'm not going to run. So I have this command that's basically like this post issuing command where it's going to say, chmod 400 that key. And then the nice part about this is that OpenVPN doesn't need to know about anything. It knows that there's going to be something this Kubernetes managed mount point at /vault/secrets, and everything's just in there. I'm not going to show how that works on the server, but I'm going to show it in a minute when we get to the VPN client, what that kind of looks like. And so the other side of this is the client side, right? So the client has a similar flow. We now bring up the second add-on called the VPN client. The VPN client is running supervisor, right? Python supervisor D inside, which spawns 2 processes. The first process is a piece of software called console template. Console template is a piece of software that was originally written for HashiCorp console to get values out of the KV storage and put them into this template file, this pre-templated file, and generate a configuration on the fly using that. It's recently been expanded to work with Vault. Previously to that, you'd either have to write it yourself, or there was a Node.js-based utility that I wrote that did kind of basically the same thing, specifically for PKI endpoints, because you have three parts of the data in there, like you saw before. Console template didn't used to support that, and so you had to use this thing. I think called it Vault PKI server or something like that. You could find it on GitHub if you're interested in how it works. And console template now does kind of the same thing, except they do it inside of Go, and it's supported by HashiCorp. So what actually happens, we're going to run console template. Console template it knows what it wants to ask of Vault, but it already has no idea about anything related to the authentication. The relationship between VPN client and VPN server, or rather VPN client and the Vault server, right, is zero trust as far as the two end parties are concerned. The only one who's managing the identity, the trusted identity, is the Vault agent, which we do authenticated with previously. So the VPN client goes through the Vault agent, and it says on behalf of me, can you ask for this secret? And it's going to request a certificate via the Vault agent. Now, when I was doing this on the server, it was kind of enough just to give it a role, and that established, right? There was established trust because we said we had trust established between, the Kubernetes cluster and Vault. But what do we do on the client side, right? Suddenly now I have a whole bunch of clients. I have a client, Isaac, and I could have another client, Katie, right, who's moderating me here in the back call. So how do I know, on the Vault server that Isaac isn't requesting a TLS certificate for Katie, right? And we do that through a whole bunch of roles. So any time a user signs up for the services that I provide, I create a user for them, and I pre-create all the roles that user is going to be locked into using the Vault ACL. They're not really ACLs, but using the Vault policy editors. And that's kind of beyond the scope of this talk, but it's really well documented on the Vault website. So I highly suggest you look into it if that's something that's going to be of interest to you. But otherwise, it's good enough to say that there's going to be a user Isaac and a role Isaac, and there's going to be user Katie and a role Katie. And when Isaac, when Isaac is making the request for Isaac.smart.home, my.home, Vault's going to be able to see, hey, well, what's the identity of the user, and then what's the role? Is that role allowed to actually be using a common name of Isaac dot? And if the answer is yes, because it's me, then it'll go ahead and make that. But if I try to create, a TLS certificate for some other subdomain, then that's going to break. And we'll see that in a moment. Assuming that things go well, Vault's going to return the private and public key pairs, just like we did on the server. Console template is going to be responsible for populating the key files, similar to the way that I said happened on the server, and we'll see in a moment. And then it's going to bring up the Vault client, the VPN client process. And the VPN client process it's just going to have the TLS certificates available, and then it's going to negotiate directly with the OpenVPN. So at this point, neither the OpenVPN server nor client know or even care that Vault's running there behind the scenes. So let's see what that looks like. These are the three console template the console template files that we're using to render the CA certificate, and the client certificate, and the client key. This looks very much the same on what we saw on the user, except for I think two big differences. Difference number one is that the common name here is going to be wildcard. And again, because we're isolated, because the VPN client plugin is isolated from the VPN identity, the VPN client actually has no way of knowing who the user is. It doesn't know if you user Isaac G or user Katie or user anyone else. So we actually have this extra step. So the first step that we do is we call Vault in auth/token/lookup self, and we get a list of the roles that you get back. and we find the first role, because I've issued all of these users. I know they have exactly one role. Otherwise, I'd have some other better way of finding the exact role name that I'm looking for. But I know that I have a role that's going to be called user.isaac. So I want the second part of that role, which is the Isaac part. And then I'm going to use the value that I just got for that role name, and extract and ask OpenVPN to issue a certificate for that specific endpoint, right? And that specific common name, which must be supplied under that specific role. And this will only work if everything matches perfectly. Other than that, everything's basically the same, right? We have the same TTL lasting for 90 days. We do the same for the client certificate. We do the same for the client key. And then what this looks like on the console template side is really simple, right? We have a pig file. We have 3 templates, right? The source is /ct/ca.crt, and the destination is going to go to /SSL/VPN/ca.crt. And that SSL directory is going to be mapped similar to the same way I said it was happening in the Kubernetes cluster. Because of the magic going on behind the scenes by the HasIO supervisor, right, the scheduler, which actually orchestrating the containers, SSL is going to be set up as a shared directory. So I know that it'll exist, between. Oh, sorry, I'm confused a minute. That's how it works on the server side. On the client side, it's all as I mentioned, it's running inside of supervisor. So there is only one container, right? So SSL is actually mapped to the same file system in the same container. So everything just kind of works. Sorry about that. The only other thing you notice here is that, these clients might be up for a long time. And actually, we saw earlier that that I set it to 90 days. Earlier on in the business, I was very aggressive. I was setting, the TTL. I was saying, well, I could just regenerate these as often as I want. And the only thing that I'm going to pay for is my own CPU. So I'm willing to pay money for the CPU so that my user is going to get security. I'm going to have it reissue every 6 hours, right? 4 times a day. I'm going to reissue the certificate. And what I didn't count on is the fact that just network fluxes, right? Because it's an untrusted network, and the internet at some parts, could be funky. Just bringing up the OpenVPN connection could be a little bit wonky after it comes down. And just because it's managing to sustain a connection and it's keeping the existing VPN tunnel alive, apparently, is not a safe enough assumption to say, well, I could just, bring it down and bring it back up, and it'll just work. Reality proved to me that just wasn't the case. So at some point, I made it a little bit longer. However, since it is running and it is changing those keys, anytime the client certificate file changes, I still send a command to restart the VPN. Right. So I just spent most of the lecture, I think, on that. We're kind of running low on time, so let's just go run through the second scenario. So the second scenario is secured centralized backups, and the way I want it to work is I just want, I don't want to make my own storage. We have great companies like Google and Amazon and Dropbox who have shared storage. I just want to use that and not reinvent the wheel. So I chose to go with AWS. And I said, I want my HasIO. It knows how to make a local backup. I just want to be able to send that backup over to AWS and keep it in my S3 bucket that I pay for, on behalf of my customers. But that's not so simple, because that means that all my customers live in my production AWS account. They're not going to get access to my production AWS account, and they're going to be commingled inside of this S3 bucket. So how do I manage the security perimeter there, right? It's a little bit different than the security perimeter, the trust relationship that we needed to do before. So we have a backup agent module, right? And we already know about the Vault agent. This time it's going to work a little bit differently. In the VPN client, we had a piece of software, console template, that was that knew how to work directly with the Vault agent. Here we're doing something different. Here it's my backup software that I'm writing that needs to directly access the Vault APIs on its own. So this time, unlike using a HashiCorp supported piece of software, I'm going to be proxying my calls to Vault directly through the Vault agent. So the backup agent is aware that somewhere, right, somewhere running on inside the HasIO ecosystem is a container called the Vault agent container, right? And it knows that somewhere inside of there is the proxy that'll take it to the upstream Vault server. So the backup agent has no idea of anything, how anything works on my infrastructure, neither did the VPN client, by the way. So what's going to happen is the backup agent is going to come up. It's going to come up in process because this is a single piece of software that's written that's Vault aware. It's going to directly request AWS credentials. Vault is going to authenticate, and using a bunch of policies is going to go to the AWS STS, the short-term token service, and it's going to generate a short-term set of credentials via AWS STS that give access to that user's portion of a specific S3 bucket that lives inside of my AWS account. Those credentials are going to be turned through the Vault agent to the backup agent, and that's it. Then we stop talking about Vault. Vault's now out of the picture. The credentials are still short term. But what happens is that if the credentials need to be renewed, the Vault agent just kind of takes care of that for it. As I mentioned earlier, the Vault agent is aware of everything that's going through it. It's not like a transparent proxy. It's a white box. So anytime the VPN, for example, if the VPN the 90-day or 60 of those 90 days go by and it needs to renew it, the VPN client doesn't have to know anything about it. Neither does console template. The Vault agent will know about it, and it'll just and things will just the magic will happen. Similarly, these STS credentials have a very short time to live also. But again, every time they're about to run out, the Vault agent just talks to the Vault server and say, hey, my credentials are about to go out. Can you talk to AWS STS and renew the credentials or update the credentials? And the magic just kind of happens mostly on its own. And then the backup agent, is able to get those credentials and just use them to communicate directly with AWS S3, which means that I don't have to be a point of failure. My server, my infrastructure doesn't have to be a point of failure between the edge devices and the S3 bucket, which I assume that S3 bucket has a much better SLA than anything that I put in the middle. And so here, what I want to show is a snippet of the AWS policy. So we mentioned earlier that Vault has a cloud credentials secret backend, and that's the backend that we're using to generate these STS calls. As an input to it, you have to give it the template of the policy that you want to generate. And this is the actual S3 policy that I'm generating. So there are two statements inside the policy. One's allowing delete object, get object, and put object to anything inside of a bucket called cust backups in directory user star, right? And here, this template, this is a bit different than console template. Console templating was happening on the client side. With this policy, the template is actually being run in the server context. So I don't need to go and look up the role like I did last time, right? So that I could pre-populate the request. I don't need any of that here. It's happening on the Vault server. The Vault server is very much aware of the user and it has already established the trust. So it just dumps the username straight into the template. It's a lot simpler, a lot cleaner. And then the second part is, similarly, in order to view whatever files you've saved there, right, we give you list bucket to the entire bucket, and then we make a condition that says as long as it's inside of the directory user slash, and then that'll just become Isaac /star or Isaac / in the second example, and things just kind of work. So that's really all we have time for today. So again, we went over the use cases of secured WAN access. We went over the use case of secured centralized backups. And like I said, extra credit for those who want to think about it at home, this idea of the secure chip configuration registry. So what we've learned here in the last 30 or so minutes is that untrusted edge, well, maybe I went a little bit overboard when I said it doesn't matter. But the idea is that, we really can have these untrusted networks. And despite the untrusted networks, there is some way of establishing some semblance of trust. And yes, if someone knows your credentials, and someone, grabs your Raspberry Pi and is looking for the clear text login, that doesn't solve that problem, right? There are always, as if anything else in security, there are always a lot of problems that need to be solved. But security, is always about strengthening the weakest link. And where the weakest link might have been, how do I access the VPN? How do I access the S3? How do I access the storage? Right? We're shifting it over and we're finding new links. And who knows, maybe I'll come back to HashiTalks in another year or two, um, to talk about other links that I've solved. Possibly not, because like I said, I'm working at Amdocs now. On that note, for more information, first of all, you could, here's my name, my email, my LinkedIn. I highly suggest that if people want to be in touch, use the LinkedIn. My new job is basically has a black hole of an inbox, so you don't want to get your stuff lost there. Use LinkedIn. And if people are interested in working with, HashiCorp's suite of DevOps tools, we're building a great use case for using them inside of the new business unit, and I'm hiring. So if that sounds of any interest, definitely be in touch. Otherwise, good luck. May the force be with you, and thank you so much for your time. Great day.